Hello, everyone. Good morning, good evening, good afternoon. My name is Paul Buffa, and today is part 2 of our Introduction to SQL course. So hopefully everyone was able to attend part 1 and is excited for part 2 today. And I'm guessing everyone can hear me pretty well right now. Just let me know if there's any audio issues in the chat here. I'm once again joined by my 2 colleagues, and here let me move my little avatar here. Allison and Wayne, who will be helping out with the course today, TAing and helping with any logistical questions that might come up. So feel free to post any questions in the chat here if you're having any issues, if you need to access something, or if you have any just general questions. We also have the community Slack channel if you want to ask questions there, which is a great spot again for kind of longer questions you might have about observable or SQL, whatever it might be. So feel free to post questions. We'll try to get to it as much as we can throughout the course today. So for today, we're going to continue where we left off last time. I can move my avatar out a little bit again. There we go. And follow up what we talked about yesterday. So yesterday we went through kind of the highest level of what SQL is, why work with SQL and databases, what is DuckDB, and then a lot about the select statement. So writing our most simple queries of selecting some data from a table and maybe doing some simple aggregation where we group by some value. So if you want to review any of the lessons from yesterday, all those documents are available to you. The notebook that we have, it's in the same collection as the notebook we're going to be sharing today, as well as the notes. So if you need those again, we're happy to share those out. So for today, we're going to get to a really important concept of SQL, which is joins. So once you've gotten through yesterday's lesson and today's lesson, you'll be pretty good when it comes to writing some basic SQL queries because you've kind of covered the biggest topics, which is selecting data from a table and then joining to other tables. So you can pull in multiple different data sets together into one single view. So we're going to talk about joins. We're going to talk about whether to join or to left join, and I'll explain what that means in a little bit. Then we're also going to talk about filters. So we're going to talk about these two clauses, the where clause and the having clause, which is how you filter your data into a specific subset. And then we'll also hopefully have time to go through a few specific operators, the in and between operators, which are really helpful when you're filtering data. So why don't we jump right in because we've got a lot to cover today, and talk about joins. So what is a join? In SQL, a join is a really crucial concept because it's how you connect two different tables together into a single view. So when we're talking about relational databases and how data relates to each other. Joins are integral into that, right? It's how the two actually talk to each other. So to employ a join, we're going to write the join clause and within your from clause. So it's where you specify the tables you're pulling your data from. You add the join logic, and you're going to mention, you're going to add in there the column that you're matching across those two tables. So it's fairly simple, nothing too crazy, but very specific syntax that you have to follow to make sure it works correctly. So here's an example of two tables, and I'll scoot this over so you can see a little bit easier. There we go. So here's an example of two tables. This is just mock data that I generated. So there's in each table, there's only two columns and there's four rows, right? So there's a column called ID, and then in table one, and then there's a column called city. So Brooklyn, San Francisco, Denver, Tampa, just four random cities. And then in table two, there's a column called ID and a column called population, which is going to be the population size for each of those cities. So this is like, simple example, but sometimes your data is going to look like this, right? You've got one table of maybe some locations, another table of some metrics. So you want to be able to combine these two tables into one single view. So joining is how we're going to do that, right? Joining is how we could take those two tables and return something like this, which has all the information from both of those tables. It has the ID, has the city, and the population. So how do we do that? The way that we're going to join those two tables is by matching those two data sets on the ID. Since we can see here, there's an ID in both tables. We can just see that there's a match, right? There's A, B, C, D. That's how we're going to join those two data sets together to return one data set. So we're going to have to specify that we're joining on the ID here. We're going to match it where ID is equal in each of those two tables. So how we're going to write this? Well, we're going to use some of the lessons we learned from yesterday. So we're going to write a simple select query. So I have select star from table one, and then we're going to join to table two. And you can see we're going to just write a join clause within our from. So it comes after we declare from the first table. We're then going to join to the second table, so table two. The last part we're missing here is just the logic for how we're joining those two tables. How are we matching them? So we have to say we're going to join on where table1.id equals table2.id. Now, yesterday we didn't get into anything with multiple tables. Everything was just looking at one table at a time. You'll notice here to call a specific column from a table. So the ID from table one or table two, I'm just going to have to reference the table name as well. So to reference the table one ID, I do table1.id, and for table two, I do table2.id. And this query will return this result here. So you can see there's a perfect match for every row there was in table one. There's also a matching row in table two. So the result is to have 4 rows with all the data in there. One thing you might want to note here is that when I looked, if I can go previously real quick, um, there's an ID column in each table, right? So there's an ID in table one, there's an ID in table two, there's a city in table one, and a population in table two. Now, theoretically, if I pulled all the data and I return the results, there'd be 2 columns called IDs since there was one in both table one and table two. Now, in SQL, and it might vary a little bit on the SQL dialect you're using, but for most part, most SQL dialects, it's going to just, if you've got duplicate names for the results you're pulling in, so you have 2 columns called ID, it's just going to use the last one that you referenced. So if you've got a first column called ID and another column called ID, it'll just use the last column called ID here and only return one of them. So it won't return 2 columns with the same column name. So I did the select star before. I could also specify the exact columns that I want to pull from each table. And again, I would just use that notation of the table name, then a period to note which column I want to pull from. So if I want to pull the ID from table one, I would do table1.id, the city from table1.city, and then the table two population. It's the equivalent of you get the same response as if you just wrote select star here, since we're pulling in all the columns. But you could specify which columns you want to look at. All right, so that's the basics of join. That's the most simple join we could do. Let's do a little activity to practice this. So I've got a notebook here. I will share out with everyone. So here we go. Here's the notebook for today. So feel free, as we did last time, to fork this notebook if you'll make a copy for yourself. Again, you need to have an observable count to make a fork of this notebook. You can also just follow along if you want to watch. You can watch, obviously, through here on the video, or you can watch in the notebook. You'll be able to see me making those changes kind of live within the notebook, too. So however you like to learn, all of it should work fine. So I'm going to move this down here so it's a little easier to see the work. All right, so we're going to get to activity 1 here, and we're going to do, again, some of the most basic joins we can use, again, with the same data set we used from yesterday. So this is this mock pizzeria data set. So the first thing we're going to do is we're going to join a few tables together. So we're going to join the stores table to the orders table and count the number of orders by the store's state. Okay, so this is going to be combining a few of the different lessons we've learned from yesterday and today. So real quick, just as a review, we can open up this database pane here. Again, you can't see my cursor, and I saw one comment there, so I was able to figure it out. Just a screen sharing thing, sometimes you can't see my cursor. Hold on, when I load this up, hopefully in a second, we'll see the pizzeria data load in. Sometimes it just takes a second to load in. Might be because we've got a lot of people doing it at the same time. Of course, now it's not going to be pulling up. Well, since that's not loading just yet, I will explain it. So we had a few different tables in that pizzeria data set. One was called stores. Another was called products that we're looking at, and there's one called orders. So we can join these two tables together to pull information from the stores table and from the orders table. So if we want to just get a quick glimpse in it, we could do a select star from stores, and we can get a quick sense of what's in that table. I might just need to refresh my page here. It looks like maybe I had it open for too long, and there were some connection issues. So let's just give this 1 second. There we go. So I think it was just because I had the window open for too long, so there was some connection problem there. So maybe now I can get the database. Yeah, here we go. Now we can get the schema overview. So here's the Pizzeria database. I can see all the different tables in there. So again, there's one called stores. We were working with this a good amount yesterday. There's an ID for the store ID. There's some information about the locations. And there's another table called orders, where we can get some info about what people ordered from this pizzeria. So we can see the order ID, a customer ID, a store ID, the date of the order, and what was ordered. So let's join these two tables together and do a little simple aggregation, again, using some of the lessons from yesterday. So we're going to join from stores. We're going to join to the orders table. So I'm going to write my join after my from here. And to complete this join, we're going to need to specify what we're joining on, right? So in the stores table, I mentioned there's a stores ID. So I'll do stores ID is going to be equal to the orders table store ID, which I believe is written that way. I can just double check. Yep, store ID. And now I've completed this join, right? So I've now been able to find a way to look up information from the stores table to the orders table. And now to finish the query, I'm just going to do a little simple aggregation to count the number of orders by each of these stores. So let me add in the stores. We'll do the state, also the city. I think here the prompt was just to do it by state. All right, we'll do it just by state. And then I'll add an account star as the num orders. Again, using the alias here as to call this as num orders. And if I run this, will I get an error message or will it just work? It will give me an error message because I need to group by something here, right? So if I just run this, it's going to say, oh, you need to group by state. It's not an aggregated value. And since I'm aggregating some results by state, I need to say that. So I'm going to add in my group by, and we'll add in the stores.state. If anyone's having issues with their fork, maybe just give it a second. Sometimes we have problems if everyone's forking at the exact same time. So just give it like a minute and refresh, and hopefully that'll resolve the issue. Okay, so I've now written a simple query that aggregates the number of orders by state and joins to the orders table. So this is the logic here for joining those two tables. Now, counting star is going to get and count all the records that are grouped by that store. I could make this a little bit more explicit if I wanted to. I could write this a little differently. So I could actually count distinct. We went through this a little bit yesterday to count distinct rows of something like the orders ID. You'll notice this returns the exact same results. I can actually even just pull both. Num orders one, and you can see it's the exact same results. So why would I want to do that? Why would I want to not just use the simplest count star? Well, sometimes you want to make sure, and if you're a data analyst and you're pulling sensitive business information, you want to be extra sure you didn't make any mistakes. And there's not, for some reason, duplicate values in your response. So if you write it this way, you're saying, I only want to count the distinct number of order IDs. There's a distinct ID for every order. This is a little bit like a safer way to write this query, because if for some reason there was a mistake in maybe your join and you had too many, you had like duplicate results somewhere, the count star might inflate your values. So this is kind of a safer way to do it, but either way is going to work fine. Okay, so that's a simple join. Let's try joining maybe multiple tables. So I can take here, let's just grab the same query. I'm going to put it in this one here. So we're going to join three tables this time: the stores, customers, and orders table, counting number of orders and distinct customers by the store state. So we're going to basically just add one more table here and also count an ID in the customers table. So to add another table to your join, so you want to join to not just one, but two tables, and you can join to as many tables as you like. We're just going to add another join clause here. So we're going to say, all right, join. So from stores, join to orders on the stores ID equals the orders dot store ID. And now we're going to join the customers on orders customer ID equals customers ID. So notice the order here. It's like we're starting from the stores table. We're then joining to an orders table. Now the orders table is joining to, see if you can see my hands here, to a customers table, right? So I'm not joining customers to stores. I'm joining it to orders. So you can join to any table in here, right? It doesn't matter if I'm joining only to stores. I don't have to only join to stores, even though it's the first table specified in my from clause. I can join to orders as well. So now that I've joined the customers, I can also pull in the number of customers. So we'll count maybe distinct customers ID as num customers. Now I've got all those results there. So again, joins, it's how you combine two tables together. Really crucial part of SQL. The way we do it is we write a join clause in the from. I call this in the from. It's basically like thinking of the from section as where you're getting all your data from. So the join comes after we declare our from clause. And we're going to join to a table, so we call the table name, and then we give it some logic of how we're going to join. So here we're just saying where the IDs match in these two tables. Any questions or comments before we move on to the next section? Yeah, so here's a question from Leslie around, so you put in what you want to count first from the tables, then join the tables. It might seem a little odd, right? Because we're saying first what we want, and then we're specifying after that kind of where it comes from. But that's right, yes. So the first thing we do is we say, oh, select this information, and then we're going to say where it comes from. So the order does matter here, right? You have to always start off with your select, then your from, and within the from, we start adding in our joins. If I did this in any other order, I would just get an error message. So if I move this down here and say, all right, from these tables, now select this. Oh, crazy. Actually didn't give me an error message. Wow, okay. All right. Maybe you can do it in DuckDB, but in a lot of SQL dialects, that will give you an error message if you do it in the wrong order there. So in general, order does matter. Surprised that didn't mess up for me, but don't do that. Do it in the right order. So here we go. So here's another question. How does it know what we are aggregating on in the second line? So how does it know here what are we aggregating on? Because we're specifying in the group by, we're going to aggregate by the store state, right? So we're going to aggregate by the state. And then what we're going to do is we're going to count all the matching results. So that's what the count star does. It's just going to say, when we're combining those two tables together, the way you can kind of think about it is, remember before when I showed that example of the two simple tables, and then you got one kind of main table? That's what's happening in this sort of query. We're not going to talk about it today. This is actually going to be one we're going to talk about one of the last sessions around how to optimize queries in the query execution order. And by query execution order, what I mean is the way the query runs, how it works, how it efficiently pulls data. So essentially what it's going on here is We're actually the first thing that's happening is it's actually is doing that join first, right? So it's combining all the information. So I have these two tables. Let's see if we can center my hands. So I've got two separate tables, and now it's combining, them, right? It's combining them all into one single table. You can think of it that way. And then it's going to start doing the aggregation and the select, and if we add any filters, which we'll get to in a little bit. So when it says count star, it's counting star on all those matching records here, right? So it's done the join, it's done the match, and now it's counting everything by whatever we group by. So here we group by state. These are great questions, though. Okay, looks like I'm going to try to get through another one or two, and then we should probably move on. So let's see here. Can you do all your joins together, then your ons? No, again, this should give you a syntax error. If it doesn't, it's definitely not considered good practice. You should write the logic for your on right away. I will talk a little bit later about this sort of older style of joins. It was actually before there was a join clause, before that was added to many SQL dialects. There was a different style for writing joins that's kind of similar to what you're describing here, but that's not considered a best practice. The reason you want to do it here is that you want to make it really clear that logic of how you're joining right next to the table that you're declaring. It can get really complicated for big SQL queries, so it's nice to keep that logic kind of next to each other so it's easy to find and understand how it works. So last question here. Are we assuming that all the IDs are unique? That no customer placed more than one order? So no, not at all. So you can see here the number of orders is much larger than the number of customers. So that means that my customers placed multiple orders together. There is a unique ID for every customer, and there's a unique ID for every order, but customers can have multiple orders. So maybe we can do a variation of that in a little bit and show what those results are. These are great questions, though. Thank you. All right, let's continue on. I'll move back to my deck here. So joins are really interesting because you might think of joins as just a way to kind of match two data sets together in the kind of sort of simplest of terms, but they actually can do many different things. So you can think of a join here in some ways as a filter, right? So say here's again an example. There's two tables. I've got this, I'll move this back here. I've got, again, this table 1, with 2 columns, an ID and a city. So the ID is unique A, B, C, D, and the cities are unique. But then I have another table 3. And table 3 is a little different than before. So there's an ID column, and there's another column for a body of water. So it says, which body of water is near this city here. And you'll notice if you look closely is that although there's 4 rows, there's only 3 distinct IDs in table 3, right? There's the body of water for Brooklyn, the Hudson River. There's 2 for San Francisco, the San Francisco Bay and the Pacific Ocean. And there's 1 for Tampa, the Gulf of Mexico. I think these are right. There's probably more. I just kind of jotted these in. But there's none for Denver, right? Denver is landlocked. There's no body of water next to Denver. So if I were to join these 2 tables together, I'd actually be somewhat filtering the results. So here's what that join would look like, right? So I'm going to join from table 1, join table 3 on the IDs. And although there's 4 results, if you look closely, there's no result for Denver, right? That got filtered out. And that is because table 3 did not have that result there, right? So I look at table 3, there's no result for Denver. So when I join on those 2, I'm filtering the results. So joins like this, and this one here is kind of just the simplest join. It can work as a filter. So something important to think about when you're joining 2 tables is that if there isn't that one-to-one match where there's the same ID in each table, you might be filtering results when you join. So we'll get to how you can handle for that in just a little bit in today's session, but it's an important concept to remember. It's also going to be really helpful for you because say you've got a really large table, right, of say, for example, that orders table. That's a really large table. It's got 2 million orders in there. That's why for some people it's loading a little slow in their notebook. Sorry, we wanted to make it a realistic data set, so it is a little bit large. Maybe I can make him reduce the n on that one day. But that's a really large table, right? And say I've got another table of just say like my top 10 best customers. If I join those two, right, those top 10 best customers to my orders table, I'm going to greatly reduce the size of data that I'm looking at. I'm only going to look at the orders for those top 10 customers because when I join, I'm filtering, right? I'm filtering on exact matches. And that can be a really good thing sometimes when you're writing queries. And again, we'll get to this in later sessions because it'll speed up your query. When you're looking at less data, it's going to make your query run faster. If you're looking at more data, your query is going to run slower. So joins as filters, it's an important thing to remember when you're writing queries, but also it can be really helpful for you because it can make your queries run faster. Another concept here that came up, which is, I mentioned how we're missing one result. So there was a missing result for Denver since there's no body of water there. There's also this relationship between what's called like a one-to-one and a one-to-many. And these are important concepts when you're doing joins. So, for Brooklyn, there's a one-to-one relationship here. There's one result in table 1 and there's one result in table 2. And that makes one total result when I join it, one row, right? There's going to be one row with the city and the body of water. But for San Francisco, there's actually two results in table 2. So that's called a one-to-many relationship. So if I join those two, I'm going to have two rows with the city name San Francisco, right? Which we saw before. So we saw that there's now two rows with San Francisco. So there's now a duplicate there, although there's a unique body of water for each one. So sometimes when we get duplicate results in our queries, it's because of that, right? It's because of that one-to-one and one-to-many relationship. And even if I didn't include the body of water here, say I just pulled the ID and city, I would still get those duplicates unless I did a select distinct, which we talked about yesterday, a way to remove duplicates from the results where you only get unique combinations of values. But if I didn't have that there, I would see duplicates in there. So it's an important thing to remember when you're joining. Am I doing a one-to-one relationship where there's only a one match, or is it a one-to-many relationship? Because if it's one-to-many, I got to think about how I want to handle that. Is that correct? Do I want to aggregate it so I'm not getting duplicate results? Do I need to do a select distinct to remove those duplicates? Or do I want duplicates? Is it there for a reason? So something just important to think about when you're doing that join logic. All right, so let's get to activity 2. And we're going to just look at the comments here. Okay. SQL is a bit unintuitive. I don't know if I would say insane, but it's a very different programming language for sure. So let's get to activity 2, one-to-one, one-to-none, and one-to-many. Oh, and I see the second part. So why is it still living? It's surprisingly SQL works very well for when it comes to working with databases. And it's funny because as somebody that kind of started off in SQL, then got way more into Python and then JavaScript, I'm so relieved that I can work in SQL again because for some stuff it actually does. Once you kind of think in a SQL mindset, it makes a lot of sense. But it is definitely strange. And I do appreciate the point of view for people who've not come from a SQL background, right? They've started off with maybe some other programming language and it feels very foreign. Okay, so activity 2. So we're going to talk about one-to-none, one-to-one, and one-to-many relationships. So I added another table to the data set last night just for demo purposes. I added a new table called California stores. There's also one called Nevada stores, which is just a subset of the stores table for those stores that are in California, for California stores, and those that are in Nevada, just for example purposes. So why don't we do one where we're going to filter our stores by joining to California stores. So we're going to select everything from stores and join to California stores to filter the results. So I'm going to write select. I'll just do a select star for now from stores. Maybe I'll select just star from stores here. Now we're going to join California stores on, and if I look at my schema overview here, I can see there's just an ID for California stores, and there's an ID as well for stores. The tables are identical. It's just one's a subset. So I can just join on those IDs. So stores.id equals California stores.id. Pull those results, and I'll see there are 17 stores, and you can see all of them are in California. So if I were to comment out this join here, so I'm just going to do comment out is two dashes in SQL. An observable, it's just command forward slash if you want the shortcut for it. So if I run this, and I don't do the join, I get all 32 stores, and then by joining, I'm filtering the results, right? So I'm joining on these IDs, and then it's going to only pull ones where there's a match. So there's only 17 that there are a match. Seeing some good comments here. So one question is, can you force one to none, one to zero joins to have an NA in the resulting table? Yes, and that will be in the next activity we're going to go through when we talk about different types of joins. So great questions. So here's another one. If joins are filters, when would you want to create view instead? So we'll talk about views, I think, later in the course. It's it's um, it's a great way to filter your results. So you can basically create a view as a filter. Um, and I think that's kind of get what you're asking for. So you would use a view as a way to filter your data through a join. Um, but that gets a little bit more complicated. So we'll get to that a little bit later. All right, so we filtered our results here by joining on these two. So let's show what happens if we filter on two tables where there's no matches, right? So I've got this select star from the stores table. I'm going to join to California stores. Now, if I join to the Nevada stores, we'll do the same logic here on stores.id equals Nevada stores.id. I will get zero results because there's no situation where there's a match on both the California stores and the Nevada stores, right? So I'm filtering results and now I'm getting zero results because there's zero matches. So it first filtered the data by California stores, and then joining to Nevada stores, there's none left. So if I removed this join here, I would get all of the Nevada stores, which we can see in the results. And if I removed the Nevada stores join, I would get all the California stores. By having both in there, it's actually removing all the results, right? So again, getting zero returns by joining to two tables. Okay, so now the next one here we're going to do is join to the stores table, to the orders table to aggregate the number of customers per store. So this is going to be similar to what we did before. I can actually even just kind of copy and paste what I had before. I mostly wanted to redo this one to show. Here, I'll do, I think it's this one here. Great. So here we go. All right. So now we've got that same query as before. It's pulling in all the stores and counting the number of orders. We could also count the number of customers we want to, right? Oh, yeah, that's the prompt here. So we're actually just going to add in customer ID, customers. Now, if we filter this by joining to the California stores table, so let's do that again. So we're going to join to California stores on stores.id equals California stores. ID. Right, we're going to greatly now reduce the results. So again, we can join to tables to filter them and get that sort of one-to-one or one-to-many. And here we have a one-to-many relationship, right? Because we're joining to orders. There's many orders for every store. And then we're going to aggregate those orders together to handle for that. All right. Any questions or comments before we move on to how we handle for those missing results? All right, perfect. So I just showed you how to do joins, a little bit about how joins work. That is just one type of join. There are many different types of joins in SQL. That join I showed you before is what's been traditionally called an inner join. So it's a situation where two tables have that match, that perfect match between the two. And if it doesn't, they're going to drop the results where there's not a match, right? So you might see a lot of charts like this to show you all the different types of joins. There's many more than this. These are just 4 that I think was from like W3 schools or something like that. So there's sort of this inner join, there's a left join, there's a right join, there's a full outer join. I will warn you that these graphs here that seem kind of interesting, they're really bad. So don't use them. Um, when we're talking about joins, there's only one thing you need to know when it comes to the types of joins. There's only 2 types of joins you're ever going to need. Very rarely you will need another type of join. The only 2 types of joins you're ever going to need is a join, which is also known as an inner join, but you just call it join. You don't need to use the inner anymore. That's kind of an older phrase for joins. And left join. That's it. Nothing else. Don't ever write anything else. If you do, you're probably making a mistake. Join is when there's a perfect match and there is a result in both results in both tables. And a left join means there's not a perfect match and there's going to be missing results in one table. And I want to handle for that. I want to include those results even when it's missing and show something like undefined or not a number. You really, really don't need other types of joins. I can go and talk about this forever, but I'll promise you, it's really, really the only ones you're ever going to need. So if you have missing results and there's not a one-to-one or a one-to-many relationship, there's a one-to-none relationship, you're going to want to use a left join because a left join is going to say, all right, we're going to match, but if the results are not there, that's okay. I'm not going to drop. I'm not going to filter. I'm still going to return whatever is in the original data set, the first table. I'm just going to now show undefined where there's a missing value. So if you want to have that perfect match, that one-to-one, one-to-many match, you're going to just do a regular join. If you want to include missing values, you want to do the left join. So why would you want to ever include missing values? What's the point of that? Don't you just want to always have results there? Well, sometimes missing values are important. It's a good indicator. So, say you've got 2 tables, and again, before I had a table when I was showing these examples of like cities and bodies of water. Maybe you want to know which cities don't have a body of water near it. That might be important information, might be a good indicator for your analysis. Sometimes information is nice to have, but not necessary. So, say you're pulling in lots of data, and body of water is like, oh, it'd be good to know, and maybe I'll note that somewhere in my analysis. But I don't want to drop Denver. I want to include them in the results. I just want to note if they have a body of water or not. So it's like a nice to have sort of information. And again, the last thing there is you may not want to filter the results. You don't want to exclude rows where there's not a match. So you want to have those missing values. It's important. So now we're getting into the activity for a left join. So how does that work? So here we go. We're going to go back to our notebook here. I'm just going to take a look at the chat, see if there's any good questions come up. So here's one. Why do we sometimes join on a column from the first table and sometimes a column from the second table? Let's see. I'm not sure if I understand the question exactly. So essentially, when we're joining a join there, we're always going to have to specify a column from each table that we're joining on. So we're going to have to say, where is there a match and what is that match logic? It always has to be from each table. If you only have logic from one table, so say I'm joining from table 1 to table 2, but I only say, the IDs from table 1. I don't say anything about table 2. That's going to create something called a Cartesian join, which again, is a little bit more of an advanced topic, but that's when you basically haven't given in the SQL query the logic for how those joins work. It usually happens when it's a mistake, like you forget to specify table 2. And when that happens, your query is going to take a long time to run because it's basically just going to pull in all the information from all the tables and try to return all of it together because it doesn't know the join logic. It's just saying pull all the information from these tables. So that's called a Cartesian join when you don't specify a column from each table. All right, so now we're going to get to left join activities. So now we're going to go back to our stores table and join again to that California stores, but now we're going to left join. So we're not going to filter the results. So I'll select star or stores dot star from stores. So before I did a join on stores.id equals California stores ID, right? That only returned 17 rows. So here, let's actually maybe pull in just like the zip code, stores.state, stores.city, pull in the California stores as is Cali. Inquiry, just pulling in a few different columns, not all the data. Now, if I want to change this to a left join, all I have to do is just add left for my join to say that this is going to be a left join, not an inner join. So when I run that, I now get 32 rows. And if I scroll down, you'll see here are all the ones where there's missing values, right? So these are all the ones where it's null and says there was not a match on those two tables. So this will show is Cali is this column. I could do the same thing for the Nevada stores as well. We'll add another column here for Nevada stores. We'll say is Nevada. Now I've got a column for is Nevada or is Cali. And there's never a situation where the two both have a result, right? And there's two situations where both are null, right? Where both don't have results there. So left join, pretty much the exact same syntax as a typical join or an inner join. We're just going to add the word left before. So let's do that query we had before where we're counting the number of orders. I can grab the one from above. So here we were joining to California stores on orders, right? We did this. It pulled all the orders and number of customers for California. I'm actually going to use the California stores. I'm going to use that column from that table here since to demonstrate a left join. So now if I left join to California stores rather than doing an inner join, still get two results now. One where California is a state and one where it's null, right? Because there's situations where there's no matching values in California stores. Those are for all the other stores in other states. And I can see all the results for those. So left join is a way to handle for those missing values there. Same syntax as a regular join, except I add left. Pretty simple. All right, any questions or comments? I will jump back then. All right, so we've talked about how you can filter with joins, which is pretty cool. There's also just clauses for filtering, which are really important. So we'll get to those now, which is going to be the where and the having clause. So in the where clause, we can filter our results based on the values that are in our tables. So if we've got a column that says something like, state name or state we want to be equal to California, we can filter that in our where clause. So we can just take the results that we have and reduce them by adding some filters. Where clause, just like before, has to come in a specific order. The way it's going to come in after your from and join logic and before your group by logic if you have a group by. So here is that query we looked at before, those simple ones where we're pulling in the cities and populations. If I wanted to filter results for just where the city equals Brooklyn, I could add this to my where clause. So I specify the table, the column, and the value that I want to filter on. Yeah, one thing that's important to note in SQL, a single equal sign is how we're going to check if these two values are equivalent. That is very different in other programming languages. Usually, a single equal sign means we're assigning a value. But here, an equal sign is just going to mean we're checking if the two values are equivalent. So, where clause is one way of filtering. Another way of filtering is going to be through the having clause. So, having functions very similar to where. But the difference is that a having clause can also filter on computed values. So by computed values, I mean something like, say, we're aggregating the number of orders by state. We have something called number of orders. If I want to filter on number of orders, I can't do that on my where clause because that's a computed value. It comes after I group by my results. So if I want to filter there, I have to do it in the having clause. So the having clause, again, order matters. It's going to come after my group by because it has to wait till all the values are computed and then it can do the filtering. So in that way, it's also a more expensive type of filtering, right? Because it has to wait until the query is run and then it filters the results rather than filtering the results while it's aggregating, basically. So you want to use having when you need it. If you don't need to filter on computed values, you just do it in the where clause. So here we're doing that same query as before. So we're looking at the city, the number of bodies of water. But here we're going to filter where the number of bodies of water is greater than one, which was only San Francisco before. So since that's a computed value, I have to do that in the having clause. I can't do that in my where because it has to be aggregated first. All right, so hopefully this will be clear as we do some activities. Oh, one thing to note, you'll see in this version here, I did group by 1, 2, rather than specifying the actual values like the ID, table 1 ID, and table 1 city. This is just like a shorthand for grouping, which means I'm going to group by the first and second column in my select. I use this a lot. I think it's nice because I don't have to write out as much, but you might see it. So something important to note. Okay, so let's get into filters. All right, so first prompt here is to filter results of the product table by category for only classic products. So I'm going to select star from products. And now I'll do the right indenting here. We're going to add in a filter, a where clause, to filter products where the category, it's just called category, equals classic. Now I've only got results where the category is classic. And if I comment this out, you'll see there are 36 rows in the data. And when I add it back in, it's filtered down to 16 rows. So we can do this, for stores as well. So if I wanted to, I could select star from stores where the state is equal to Utah, right? Only one result here. Pretty simple. Okay, so now let's do one where we have to use a having. So let's filter the stores by state. We're going to only do ones with state equals Nevada. We'll do it with a where clause rather than through our join, which we showed before by joining to the Nevada stores table. And then we're going to aggregate the number of orders. So let's do here. So we're going to join to orders on stores.id equals orders at store ID. Orders state is equal to Utah. We'll pull in stores state. And then we'll do a count distinct orders ID as num orders. We'll also have to do our group by, right? I'll just do the 1. So that's the first column. I'm going to group by state. Here we go. Oh, sorry. The prompt here was to group by do for Nevada. If more than one result. Include the city name, so we get more than one result. There we go. So here's all the stores in Nevada showing the number of orders, right? Now, if I want to just filter for those that had over 100,000 orders, I would now add in my having clause. So having It's going to be, again, after the group by, because I have to wait till my results are aggregated. And now I can just say where num orders, and I can reference the alias that I created, greater than or equal to 100,000. Now I can get those two stores. So I couldn't do this in the where clause because that's a computed value. I could include here in the having clause, number of stores dot state equals Nevada, right? I could do that here. Add in some more logic here. I'll get into and ors as well. Turns the exact same results. But in general, it's considered good practice to always filter early on, as early as you can. So where happens before having, and since I could do that earlier on, I'm going to do that there again because it just reduces the number of rows that I'm looking at, right? It shrinks my data set down earlier on, which will make my query run a little bit more efficiently. Oh, and yeah, here's the question here. What is that 1, 2 reference in the group by again? That's just referencing the first and second column in my select. So whatever I put in here in my select, if it was city and state or state city, that's going to be the first two. It's the same thing as writing out stores.state and stores.city. Just basically a shorthand for it. There's many disagreements, I think, among SQL writers of whether it's better to use the abbreviation or writing it out. You can argue one's a little bit easier to understand later, the other one, it's nice, it's easier to write. I like writing just the 1 and 2, but you should do whatever you like. Okay, I'm just going to do a quick check on the questions again. I think there's 2 from before I missed around left joins. So there was one. So is left equal or anything else and right? So I think the question here is like, is left join and right joins the same thing? So hopefully I'm interpreting this correctly. So theoretically, left joins and right joins are basically the exact same thing, which is why I would say just stick with left joins. Like you don't need right joins because they do almost the exact same thing as a left join. It's just about the order, right? It's the order. So like a left join and a right join are basically it's the mirror opposites, right? They do the same thing, but it's in a different order. So I would say just stick with left joins because they're going to function the same way as a right join. You would just swap the order in which you're joining one to the other. Hopefully that answers your question. And then there's another question here. How come the first left join you didn't have to do a group by? I only have to do a group by if I'm aggregating results. So I don't ever need to do a group by if I'm just pulling in data. A left join does not mean I need to do a group by unless there's some sort of aggregation going on. So those two concepts are kind of separate, right? You can do left joins, just pull in a bunch of raw data without any aggregation at all. Great questions. All right. So I want to be conscious of time. We got 6 minutes left, and I want to get through just a couple more concepts for the rest of the day today. So, quick notes on something. I'm going to do this very fast because for some it may not be interesting, which is called ANSI-style joins. So ANSI, if you work in other industries that have a lot of standards, I was talking to an engineer friend of mine who knows all about ANSI. It stands for the American National Standards Institute. There's a lot of areas where we need standards, like for example, how your keyboards are designed and the order of keys is like a standard that's agreed on by ANSI and the ICO. There's standards in SQL considered best practices that you should use. So what I've been going over today, how we write joins, is called an ANSI-style join. You might see that come up sometimes. Because it's considered the best practice for how you write joins. It's not the only way you can write joins. So I mentioned this before. Someone was asking, can I just call all the tables and then write the join logic? That was the sort of older world before we had a join clause of how you would do that. So you could see here, these two queries are the exact same in terms of the results. One, we do sort of the proper ANSI-style join, and one we do the old world, where one we specify a join clause and the join logic. In the old world, you would actually just list out all the table names, and then in your where clause, describe that join logic, how those two tables matched. And we don't do this anymore because it's confusing. It's hard to figure out that logic of how these two tables relate to each other when you write it in your where clause, because you might have other filters in your where clause. And now it's hard to figure out what's part of the join filtering and what's just my sort of general filtering. It's considered best practice to do the former here, the ANSI-style join. So yeah, following ANSI-style guidelines, always cool, always in fashion. All right. So last section, just the last few minutes here, are some helpful operators that's going to come up a lot when you write your joins and your wheres and your having. And these are ways to just add more logic, right? So before we're joining on a single ID or we're filtering on a single value, you can add to this with these different operators. So the AND operator is a way you can add more logic. So I can filter on, the category of my product is classic and the size is for extra large pizzas, something like that. I can add more logic there. I can also use an or. So I can say, where the category is classic or vegetarian, right? I can filter on one of those. The last one here, it's a really great one to use for numerical values or date values, is between. So I want the values to be within a range of values. So you see this a lot for filtering by dates. Say I want it where the values are from January 1st to February 1st. So it's going to be between these two dates. Another helpful operator for doing filters. So we'll just walk through a few of these in the last few minutes here. So activity 5, say I want to filter products based on size and category columns. So I'll do again, select star from products, everything in my products table. I'll add in where the category equals classic, 16 results, and the size is equal to large. Now I get 4 results. So I can just add to this, right? I can add my logic. I can add my filters by putting in an and there. I could also put in an or. So I could say where size is large or size is small. Now I get 8 results. Notice here when I do that, I have to put this in parentheses. And this is getting to some sort of how logic works, right? If I didn't have a parentheses in there, it's going to treat it a little bit differently. So it's going to say where category is classic and size is large or size is small. So I can pull then situations where the category is not classic and the size is just small. By putting this in parentheses, I'm saying, well, category has to be classic, and then I can say size is large or small. So parentheses are important there, right? You want to add that depending on what you want to have that or work for, right? Which two logical conditions are you saying you can have an or situation? So here I just want it for the size. All right, last one here. We'll do a quick example of a between. And I'll save these. I can talk about these next time. These two last examples won't have time for today. So say I want to select all the orders. I have this table of order by product day, which is just an aggregated version of the orders table. So I can select star from here, but I want to do it where my order date, I believe it's called order date. I'm just checking here real quick. Yeah, order date is going to be between two dates. So I'll do 2021 January 1st and 2021 February 1st. The between allows me to specify a range of values. Again, it works well for dates and numerical values that I want the results within. All right, we are at time. I want to be conscious of time because everyone, I'm sure, is very busy. But that was what we had for today. We went through joins, left joins as filters, one-to-one, one-to-many relationships, where, having, and a few of these helpful operators. For next session, we're going to have it next Tuesday, so June 6th at 9 a.m. Pacific time, and we're going to talk a lot about really helpful functions that you're going to want to know in SQL. So, various types of aggregation functions, case statements. So, that's how you can write some conditional logic within your SQL queries. More types of helpful operators for filters, the in, which allows you to filter by an array, a like statement, and wildcards. And then we'll also talk a little bit about with statements, which gets to one of the earlier questions around views. So thank you so much. Again, feel free to follow up with any questions here in the chat or within our community Slack. And I look forward to seeing you next week. Thanks all.